Welcome to 2015, question B1. Thousands of satellites, such as the one in the image on the right, are in orbit above the Earth. They are used for a variety of purposes, including communications and weather research. So on figure B1, it shows the plan and elevation and auxiliary view of a model of the Earth. So we've got our plan elevation and auxiliary elevation there of our model of the Earth. Okay, just a sphere. The position of a satellite S, which is used to beam television signals back to the Earth, is also shown. So S here, S, and S here beaming down on top of the Earth. The satellite is in a fixed orbit above the Earth, and the beam has an angle, or has a beam angle of 30 degrees. So beam angle there, you can see of 30 degrees. Aimed directly at the Earth, as shown in the auxiliary view. The beam angle limits the transition area with a circular outline on the surface of the Earth, which is shown as an ellipse in plan. So that's important, we've got an ellipse in plan. So we can see it's beaming down. It's a circular shape in reality, but as it appears in plan, that I suppose circle is at an angle. Okay, it's not quite directly on top of it, we're seeing it at an angle there, as shown in the auxiliary view. So it appears as an ellipse. Okay, same way as if you have a masking tape. If you look straight down on top of it, it appears as a circle, but if we kind of tilt it and look at an angle, it gets more and more like an ellipse, or more pronounced. But this is just ever so slightly at an angle. So we're getting something like that. It's an elliptical in shape. So they want us to draw the given projections, clearly showing how the elliptical transmission area is located in plan. So basically they want us to redraw exactly what they have in there. So start with that. Should be quick enough to set up. Scale 1:1, so we'll take every measurement as we see it. So X, Y line. Okay. Project up a line here to represent the center of our spheres. So for the elevation, we want to go up 20, and then the diameter there we can see in plan is 90, so radius 45. Plus 45 is 65. Okay, and I'll actually, while I'm at it, I'm going to find the center here, which is the same, down 20 and 45. And 45 into 55. Okay, compass, set our radius to 45. And same in plan. Okay, so beam S then is 15 degrees off center, a distance of 150. So I actually know just from doing kind of quick maths on that, if that's 15, okay, this is 15, that leaves 75 here, and instead of having to measure that, I can do it kind of quickly by adding a 45 degree angle and 30 degree angle. That's 75. So I can actually draw that line nice and quick without having to measure it, or without having to measure the angle. I can come back now and measure my 150. that's point S. Okay, now we can project down. I just move this up slightly on the page on the screen. Okay. So the plan view then, we need to find S, so 45 degrees from the center. And we can project that vertically down then from the elevation. Quite a distance to project there. Yes, that is point S in plan. Now we need to draw our auxiliary, which is looking in perpendicular to S, so it's going to be out here at 45 degrees again. XY line. This also. Okay, so this is our X1, Y1. Okay, height's taken from our elevation because it's an auxiliary elevation. Center. And then okay, I don't this won't go far enough, so I'm actually going to measure this if I can. Okay, let's draw our sphere, or the representation of the Earth in our auxiliary. Okay, and we'll draw straight back to the center here from S in the auxiliary. S. Now, in the question, they're telling us that the beam has an angle of 30 degrees. Okay, so that's the center of our beam that we've got drawn here, so we need to go 15 degrees either side of that. Degrees, and I'll just double check that's 30 then. Yeah, I'll do that. So here's my beam of light. and we'll join those together. Okay, so we've got our projections of our elevation done, auxiliary elevation done, but our plan view now, we just have that, as we said, elliptical shape to do. So for an ellipse we need our minor and our major axis. Okay, with this we're just going to imagine the beam of light. So here we have our beam of light. Okay, it's not exactly the right size. So beam of light, we are being cast down on top of it. Okay, creating that circular pattern. Okay, but as we look down on top of that, then in our auxiliary, it's kind of something like this. Okay, so looking at that, the diameter of this hasn't changed in this direction, but this way, okay, running across it, it's gotten shorter. It's gone from being the full diameter across here to shorter. Okay, and we can see that shorter distance up here in elevation. Okay, so imagine looking down on top, we've got the center. We're going to project that back at 45 degrees to our plan view. First of all, find the center line. Okay, now the diameter of that sphere, or of that circle, is going to be the same down here for the major distance. Okay, so I'm going to get that radius. I'll draw it down here. That would be my major circle. Okay, now our minor circle, right, as we said, we're looking down on top of it, so we can see that distance has, I suppose, decreased from this distance to there. Okay, so we're just going to project those down onto, I'm going to project them down onto a 45 degree line, or even I can actually project them down here. That's find my minor distance. Okay, so now I can draw my minor circle with that radius that I've just found. Okay, so the length of each of those isn't very, very different, okay, between my minor and major, but I'll still follow the same construction I usually would. Everything's at 45 degrees. So, because it's at a 45 degree angle, I'm just setting everything up against my 45 degree set square. It's kind of tricky to do just because where I've positioned it on my drawing board, so I'm actually going to revert back to my protractor and measure my 60-30. Okay, so we can draw a freehand curve for our ellipse here. So when we're drawing a freehand curve, we always look at the point we're travelling towards, okay, and that will give us a nice gradual curve. Okay, don't look at the point of your pencil. As you reach that point, you look on to the next point here. Eyes just jump to the next point as you arrive. Okay, so there's our ellipse. Okay, so we completed our view there. Draw the projections clearly showing how the elliptical transition area is located in plan. Done. Right, now we want to draw the outline of the transmission area in elevation, including hidden detail. Okay, so what we want to do here, this is intersecting or interpenetration really. So we want to find points on our elliptical shape and transfer them up here. Okay, there's a couple of different methods. The method I'm going to use is using horizontal sections. Okay, so any sphere, okay, if I take a horizontal cut through it, it will create a circular profile. Okay, so for example here, if I've got a sphere, if I take a horizontal section through it, the outline it will create is this circular profile. Okay, so if I take one at each point that I'm looking for, okay, that will result in a horizontal profile. So I'll just do one point and you'll see from there. So okay, kind of something to need here. I'll just use all the points that I have in my ellipse. Okay. Actually, a quicker method, just looking at it here, I have an auxiliary. So if I actually project up these points onto the corresponding, I suppose, edge view of that ellipse, that will give me heights that I can transfer over here. So I think that's actually quicker. Okay. What I could do, just to kind of talk through it with that horizontal section method, is, for example, this point here, right? If I take a horizontal section that contains that point, okay, that would create a circular profile. Okay, so imagine there I've drawn from the center here, circular profile all the way around. Now, where that circular profile touches here, I can project that up, and that would find the corresponding edge view of that profile. Okay, so I could rotate to here, bring it up until I hit the side of my sphere. Okay, horizontal line across, representing horizontal section, and project up onto it. So that's one method. Okay, but as I said, I'm going to go for what I think is a quicker method here. So project up points on my ellipse. Okay, to make this easier, I'll just number off my points. I'll go 1, 2, 3, 4, 6. Okay, it'll just be easier to follow my numbers. So I've got 1, 7, 2, 6, 3, 5, 4, and then down here I've got 8, 12, 11, 9, and 10. Okay, so I'm going to project up each one of these points. Okay, so let's start with 10, height of 10. Draw 10 down and up. There's 10. Height of 11 and 9. So 11. 9. And 8. So remember, the reason why I have to do this is we've created an auxiliary elevation. Here's an elevation, so they share the same heights. So 1 and 7. 6 and 2, 6, 2, 3 and 5. Finally then with 4. Okay, so we found all our points there. Just going to label them up again. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay. Now the important thing is they said also include hidden details. So imagine there as it moves around from between 5 and 6 and 11 and 12, it will turn from being heavy to hidden details. So strong goes heavy first. Okay. That turns into hidden detail then. Okay, so that is everything we need yet. We don't need to show the beam of light, the full beam of light. We just need to show the profile of it there. So that was the 2015 question B1 question completed.